Okay, so the basic formula for work, W is equal to integral F dot ds. F is of course the force, the work done by which you want to calculate. Can one of you quickly tell me what ds means? Ds of course is the small displacement of what? In the calculation of work, displacement of what are you supposed to consider?
So the particle on which force is acting.
Correct. You call it as the point of application of the force. Fine. And as I said, for now in this chapter, we are only going to consider solid objects without rotation. So if it's a solid object which is not rotating, the entire object undergoes the same displacement. So every particle of the object undergoes the same displacement as the object as a whole. Okay. So you can say S is the displacement of the object, but only if there is no rotation. Fine. Now in your worksheet, I had asked one question. Just a moment. Let me take the question. 1 second. And I got answers from only 2 of you for the worksheet. Others also try to answer it and send as early as possible. Yeah, this question. Imagine a person climbing up a flight of stairs. As the person climbs up, see, you know that there will be a normal force acting on the person's feet when the person is climbing up. The question was work done by the normal force acting on the person, okay, is positive, negative, or zero? Vanilla, what was your answer?
Zero, sir.
Okay, you said zero, and why?
Sir, because normal force is perpendicular to the displacement.
Because normal force as a vector is perpendicular to the displacement vector. Why do you think it is perpendicular? See, in this case, you can see the person's foot, the steps and all. In which direction is the normal force acting on the person's foot?
Upwards, sir.
Upward, vertically upward. Okay, normal force acts perpendicular to the surface of contact. In which direction is the person moving? Person is not moving horizontally. Person moves at an angle like this, no, while climbing stairs. The angle between them is not 90. Okay. Any other answers? Anyone? Pawan, what do you say? As the person climbs up, work done by normal force acting on the person is positive, negative, or zero?
Sir, positive.
Why?
సార్ పర్సన్ పైకి వెళ్తున్నప్పుడు అంటే డిస్ప్లేస్మెంట్ అంటే కాంపోనెంట్ అని.
Okay. Okay. So this is the force and this is the displacement of the person as a whole. And the angle between them is acute. It is less than 90 degrees. So he's saying that is the reason the work done is positive. We'll see. We'll see. Positive because angle is acute. Aishwarya, do you have any answer?
No, sir.
What do you think?
It's a positive.
Okay, same reason.
Yes, sir.
Okay. See, basically the sign of work is always determined by the angle between the force and displacement. Okay, if the angle is acute, the work done is positive. If the angle is 90, the work done is zero. If the angle is obtuse, work done is negative. Or if any one of them is zero, the work done is zero. Okay, that possibility is also there. Rishi, what do you think?
Sir, I think it should be positive only.
Same reason?
Yes, sir.
Okay. So One of you gave this answer. 3 of you think it is this. Use of any answer? As the person climbs up the stairs, the work done by normal force will be positive, negative, or 0. Okay. See, I'm not going to tell the correct answer, but your explanations are wrong. Both explanations are wrong. I'm not going to tell which is the correct answer, but explanation wise, both are wrong. Okay, so you all think about it once again and send me an answer. Don't ask teachers. You can discuss with your friends if you want. Okay, I think there was one more question also in the worksheet. Just a moment. This runner case. For this also, think carefully and come up with an answer along with an explanation. As the runner gains speed in the forward direction, we know to gain speed, we need friction from the ground. Okay. As the runner gains speed in the forward direction, work done by friction on the runner is positive, negative, or 0 is the question. So both these cases, think carefully. If you want, you draw diagrams and keep, you think over it. Send me an answer by tomorrow. And in next class, I will explain the solution clearly. Okay. And in that worksheet, you had one more question also. Work done is integral f dot ds, where ds is the displacement of the point of application of the force. Displacement is a relative term. Like how much displacement an object undergoes depends on the reference frame. Okay, like we had discussed that elevator case, no? Person standing inside an elevator or weighing machine inside an elevator, block inside an elevator. Now, with respect to elevator, the weighing machine is at rest. Displacement is 0. But with respect to ground, the weighing machine goes up and down along with the elevator. It is getting displaced. So displacement is a relative quantity. Okay, relative measure. Does that mean that the work done by a force is also relative to the, or it also depends on the reference frame? Vanilla, what was your answer? Anyone? Any answer?
So my answer was yes.
And that is correct. Okay. Work done by a force depends on the observer. Okay. Usually in any question, if they don't specify the observer, you will assume it is with respect to ground. But remember this, work done by any force changes depending, can change depending on the observer. You can never say that work done by a particular force is always 0. If there's a non-zero force acting, but just by changing the reference frame, you can change the amount of work done. You can make it positive, you can make it negative, you can make it 0. Okay, let us discuss one example. Okay, let's consider that elevator case itself. I'll just draw a rough diagram. Let's say there's a box inside an elevator on the floor of the elevator. And assume there is one person here. Call this person as A inside the elevator along with the box. And let's say there's another person on the ground, B. Assume the elevator is moving up. If it is moving up, the box is also moving up along with it. Okay. One of you tell me what forces act on the box as seen from the ground. What forces act on the box? What are
Normal
the
and weight, sir.
weight and normal, the usual forces that we consider? Okay. These are the forces that act on the box with respect to the observer B, who is on the ground. With respect to observer A, what additional force are you supposed to consider if you want to apply Newton's laws?
Pseudo force.
Pseudo force. But you need to do that if the elevator is accelerating. Simply moving up doesn't mean accelerating. It could be moving with constant velocity also. We don't know. Let it be. But with respect to that observer also, normal and mg must be considered. In addition to that, you will have to consider a pseudo force if the observer is non-inertial. Hope you all are clear with this. Okay. Now let's say the elevator moves up by a distance of some, let's consider y. Okay, it moves up by a distance y. Now, if elevator is moving up by a distance, the person on the ground will be able to notice that. The person standing inside the elevator won't be able to notice that. So with respect to ground, that means with respect to the observer B, who is on the ground, work done by normal force on the block. Can one of you tell me how much it will be? Let's say the magnitude is n itself. Okay, let's not even equate it to mg or m into g plus a or anything. Take the magnitude as n. The displacement is y. You see their directions, angle between them, and tell me what is the work done by normal force on the block.
N into y, sir.
N into y. Okay. F s cos theta. We assume the normal force to be constant. Then we are using F dot s, Fs cos theta. So it becomes the force is normal force n, displacement is y, angle between them is 0. So it simply becomes ny, which is a positive work. Makes sense. Let it be. Rishi, tell me, what is the displacement of the box with respect to the observer inside the elevator? Okay, Aishwarya, you tell me, what is the displacement of box relative to observer inside the elevator?
0, sir.
0. Then what will be the work done by normal force with respect to that observer? If displacement is
0, sir.
0, if displacement is 0, work done by any force will be 0 itself. Okay, so it is true that the work done by a particular force depends on the observer because displacement is a relative term. Forces are not relative. Normal force, the magnitude is same whether you ask A or B. You put a weighing machine there, it will show you how much normal force is acting on it. So forces don't change relative to the frame. Of course, in non-inertial frame, you will need an additional force, but the existing forces won't change. Displacement changes relative to the observer. Therefore, work done by a force changes based on the observer. So in questions, if they don't specify a reference frame or an observer, you will assume it is with respect to ground. Okay, keep this point in mind. You all can note this down. Work done by a force is relative. That is, it depends on the frame of reference. Okay. Let's solve some more problems based on calculation of work. Last class, we discussed block being dragged on the floor, block sliding down an incline. Let's consider some more cases like that. Or, okay, let's take a variable force. Suppose there is a force F is equal to 2x I cap in newtons. So based on the x coordinate of the object, the force changes. Okay, so F is equal to 2x I cap. And let's say an object of mass m, mass let it be 3 kg, moves from x is equal to 2 to x is equal to say 5 meters. Along the x-axis, the box is moving under the influence of this force. Okay, calculate work done. Try this, all of you. It's a variable force. One of you quickly tell me the formula that you will use to calculate work done by a variable force. Vanilla, don't answer. Someone else tell me what is the formula for work done by variable force.
The integration of Fs cos theta.
See, you won't integrate Fs cos theta. You will integrate F ds cos theta. Okay. Anytime if you ever have to integrate anything, there should be a ds, dx, dy, d theta. That small term should be there. Okay, let me clarify this. I know it's a, like you may have told that out of like it seems like a silly mistake, but it has a meaning. Integrating Fs cos theta. See, F is the force, a finite value. S is the displacement, total displacement, a finite value. Theta is a finite angle. So these are all finite numbers. You can tell how much they are. And integration means summing them up infinite number of times. If you add a finite number, which you can specify infinite number of times, the answer will always be infinity. Okay. But if you are integrating something like this, ds is so small an interval, you can't even tell how much it is. This is infinitesimal. Infinitesimal means it is very, very small. Even if you add infinite such small terms, the answer is going to be finite itself. Okay, so whenever you integrate, that d something term is compulsory. Keep that in mind. Okay, so I'll write the formula here. What you need to do is integral f dot ds, that is integral f ds cos theta. Now see, there are three terms that you need to consider to calculate work. One is the force, one is the displacement, and the other is the angle between force and displacement. So you should visualize what exactly is happening. Let us do that first. Assume this is the x-axis. Let this be x is equal to 0. The object is moving from x is equal to 2 to x is equal to 5. So let this be x is equal to 2. And let this be x is equal to 5 meters. It was here initially. And throughout the journey, like it is taken straight from x is equal to 2 to x is equal to 5. So the displacement or the small displacements, if you see, they are all in this direction. These are the ds displacements along the journey. You have to visualize all this. Only then you will get correct answers. Your chances of making mistakes will go down, okay, if you can imagine the situation correctly. And then there is a force acting on it. The force, you notice this force, 2x I cap. What is I cap? Anyone? What is I cap?
Unit vector in positive x direction.
It just indicates the positive x direction. That's fine. And from x is equal to 2 to x is equal to 5, all values of x are positive, means the force is always in the positive x direction. Okay, you have to understand what the equation is telling you. 2x I cap, force depends on the x coordinate. And if the object is moving from x is equal to 2 to x is equal to 5, all x values are positive, If all x values are positive, means all force values will be positive. Means the force always acts in the positive x direction. Why is this important? It helps you find out the angle between force and displacement. Now solve the question, all of you. Type your answers in chat. I got two answers as 21, both from girls. Girls are doing calculation very fast. Okay. Fine. Pawan, tell me, how are you trying to solve this?
సార్ జస్ట్ ఆ కాంపోనెంట్స్ అక్కడ సబ్స్టిట్యూట్ చేస్తున్నాను.
Okay. Listen, all of you. As I said, you need to be very careful. Now, the green vectors indicate the force. The orange vectors indicate the displacements. Now we need F dot ds, and we know how to do dot product. Let us use all that here. W you can write it as FDS cos theta. You can use this formula. Integral. Since x is always positive, the magnitude of the force can be written as 2x. Not an issue. If there is a chance of x becoming negative, then magnitude cannot be 2x, because magnitude of a vector can never be negative. Direction plus minus you can have, but magnitude cannot be negative. So you need to be careful there. Okay. In this part of the displacement, from x is equal to 2 to x equal to 5, since all x values are positive, 2x will always be a positive number. So wait, f ds cos theta, no? F is 2x. The magnitude of the force. Now you won't write I cap, because we have evaluated the dot product. The result of dot product is a scalar. It won't have direction. Next, theta, the angle between force and displacement, as you can see in the diagram, it's always 0. Force and displacement are in the same direction. So theta is always 0, theta always 0, makes cos theta always 1. So you will need to integrate 2x ds. The ones who gave the answer, how did you integrate this?
So integration of x is x squared by 2 and
But vanilla, integration of x with respect to x is x square by 2. Okay. But here you are integrating with respect to some other term s. How can you say that is x square by 2? Can any of you tell me how to proceed after this?
సార్ డిఎస్ బై డిఎక్స్ చేసుకుని డిఎక్స్ అనుకోవాలి.
What did you say? ds?
సార్ అంటే సరిగ్గా గుర్తులేదు సార్, కానీ అంటే సంథింగ్ డిఎస్ బై డిఎక్స్ చేసి దాని నుంచి
See,
డిఎస్ వాల్యూ
it's
కనుక్కొని
not about memorizing stuff. It's about understanding. Listen, ds, what is the meaning of ds? Pawan, you only tell me. What is the meaning of small displacement? Correct. I'm discussing this with all of you. I'm taking answers from Pawan, but all of you listen. ds is basically a small displacement. Okay. Pawan, what is the definition of displacement?
Sir, just initial part and final part will depend also.
What is the basic formula for displacement based on its definition? Yeah, it depends on the initial position and final position. But how do you calculate displacement?
x2 minus x1.
x2 minus x1. Good. Change in position. Now this object, listen all of you, this object is moving along the x-axis. Okay. So a change in its position can be written as the final x coordinate minus the initial x coordinate. So since object is moving on x-axis, displacement can be calculated as change in its x coordinate, final x minus initial x. And if you want small displacement, you can call it as dx also. So you need to justify how you can replace ds to dx or how to convert ds to dx, that you have to see. Okay. And since the object is moving along the x-axis, when it goes from, let's say, this point to this point, the small displacement that it undergoes is the small change in its x coordinate. So ds here, in this case, in this problem, ds is same as dx because the object is moving along the x-axis. So it is safe to write ds as dx, and the integral can be converted to 2x dx. You can't blindly do that. You have to justify that. Okay, hope this is clear to all of you. And then you substitute limits. The object is moving from x is equal to 2 to x is equal to 5, I suppose. Yeah. So you will now need to integrate this. So did you all understand how we are replacing ds with dx and how it is reasonable to do so in this case? Any doubt in that? Okay. So now if you want to calculate work done by the force in this case, just integrate, substitute limits. Integral 2x, 2 you put outside, integral x dx is x square by 2. The 2's get cancelled, 2 to 5 are the limits. So 5 square 25 minus 2 square is 4. The answer is 21 joules. Force and displacement were in SI units, so the work done will also be in SI units. Last class, did we discuss SI unit of work or not?
Yes, sir, we did.
We did. Okay. So this is an example of a variable force, work done by a variable force. Let's try another case. Any doubts in this? Anyone? Okay. See, later when you revise, you have to recollect all the points that we discussed while solving this problem. The solution seems simple, integral to x dx. But there are a lot of considerations that we made on the way. The force was 2x I cap. X coordinates are all positive. That's why magnitude is 2x. We can take as it is. Okay. And how did we replace ds with dx? There is a reason behind that. You can't blindly do that. Okay. Let's try another case. Just a moment. Fine. We'll take this case of block being dragged on the floor. Let's consider a small box. Small box means its dimensions are negligible. Okay. Let's say the small box is initially at x is equal to 0 and it is dragged all the way, okay, along the floor itself. Along the floor itself, it's dragged to, let's say, x is equal to 10 meters. So this is the initial position of the block. This is the final position of the block, and it is taken straight from this position to that position. You can call this as A and B. Assume it's a rough surface, and this time the coefficient of friction is variable. Let's say coefficient of friction varies as, or it varies with the x coordinate, means from point to point the coefficient of friction varies, and it varies as 0.01, or let's take 0.05 into x. What does that mean? When x is equal to 0, coefficient of friction is 0. So here the surface is smooth. Just at the initial position, the surface is smooth. Now at some point, the x coordinate will become 2. If x is equal to 2, 0.5 into 2 becomes 0.05 into 2 becomes 0.1. So here the coefficient of friction is 0.1. It's becoming rougher. Okay. Let's say x is equal to 5. 0.05 into 5, 0.25. So coefficient of friction is 0.25. Roughness has increased. Okay. So it's a surface whose roughness changes from point to point. That is what it means. Calculate work done by friction, as it is dragged from x equal to 0 to x is equal to 10. And we are dragging it by applying a horizontal force. So vertically, there's no disturbance. We are not disturbing the normal force and all. Calculate work done by friction as the block moves from, or block is dragged from A to B. Okay, solve and type your answers in chat. I got one answer as 2.5 joules. That is wrong. Okay. I didn't get any answers after that. You were asked to calculate work done by friction. Block is getting displaced towards right. That is obvious. Tell me, in which direction does friction act on the block throughout the journey?
Towards the left, sir.
Towards left. What kind of friction acts?
Kinetic friction.
What is the formula for kinetic friction? Okay, mass was not given. Maybe that's why you all didn't answer. You can ask, no? To calculate work, you need mass. Take the mass of the block as 5 kg. Anyway, kinetic friction. What is the formula for kinetic friction? Vanilla, how much mass did you assume?
Sir, you said like the box doesn't have any dimensions, so I didn't assume any mass.
Without mass, how can... No.
Like you said, negligible. So
See,
I didn't
dimensions are
assume.
negligible compared to the displacement that it undergoes, 0 to 10 meters. Okay, but it should it should have some mass. Anyway, let's say the mass is 5 kg. One of you tell me, what is the formula for kinetic friction?
Mu into normal force. Sir.
Mu k multiplied with the normal force, correct? Mu k here is 0.05 into x. The normal force on this block will be balancing its weight, so 50. 0.05 becomes 0.5, this into 5, 2.5 x is the friction, where x is the x coordinate of the object. And you know direction of friction is always backwards, and the block is moving forward, means the displacement is always forward. So all the ds vectors are in the forward direction. The force is in the backward direction. Angle between them is 180 degrees this time. So if you want to calculate work, tell me the force, it is friction whose work you need to calculate. Is this constant or variable? As the block moves from x is equal to 0 to x is equal to 10. Pawan, what do you think?
Sir, friction.
Is it constant or variable?
Sir, friction variable అవుతుంది.
What did you say?
Sir, friction variable అవుతుంది, sir.
It will be variable. And what does it vary depending on?
Sir, x value.
X value, the x coordinate of the object. Correct. The force here is a variable force. So based on that, you will decide which formula to use for work. And now it is clear you will have to use integral f dot ds. Okay, which is integral force, displacement, cos of angle between them. The force here is friction to 2.5x. And from x is equal to 0 to x is equal to 10, there are no negative x values. So for all positive values of x, this will come out positive. So you can take the magnitude of force as 2x itself. Okay. And Aishwarya, you tell me, can we call the displacement as dx? Is it reasonable or not?
Sir, yes, sir.
Yes, because the object is moving along the x-axis. So displacement will be taken as dx. And what is the angle between force and displacement at any instant? Any of you? Friction is acting backward, displacement is forward, angle becomes 180 degrees. At all times it is 180. Okay, so theta is a constant. Cos 180 is -1. So -2 can be put outside. You'll again get integral x dx, and this time the limits will be from 0 to 10. So -2 times integral x dx is x square by 2. Limit 0 to 10, the 2's can be cancelled. The answer is -100 joules. Oh wait, it is 2.5x, right? Okay. Not 2x, the force is 2.5x. So -2.5, integral is x square by 2, limits 0 to 10. So minus 2.5, you keep it outside. If you substitute upper limit, it will be 100. Lower limit is 0. Whole divided by 2. 100 by 2 is 50. Or 2.5 into 100 is 250, divided by 2 is 125. The answer is minus 125 joules. Go through this once again, ask if you have any doubts. Yusuf, did you understand the solution? No response. Okay. Others? Rishi, is it clear?
Yes, sir. Yes, sir.
Pawan, did you understand?
Yes, sir.
Why were you not able to solve it? నీకెందుకు రాలే ఆన్సర్?
సార్ ఆన్సర్ వచ్చింది సార్, కానీ ఎమ్ టర్మ్స్ లో వచ్చింది, ఇంకా కరెక్ట్ గా ఏమన్నా అయిపోయింది.
Then you could have asked, no? Okay, okay, fine. Next, let's consider another case. Let's assume there's a rigid support, and with the help of a string, we connect a stone or a bob to that rigid support. It's somewhat like a pendulum, you imagine. Okay. As you can see, the stone is pulled aside, and assume it is released from this position. You all tell me, in a real life situation, what will happen when we release the stone from rest?
Sir, it'll start oscillating.
Oh, correct. It will swing along an arc. Okay. So it will follow a curved path, somewhat like this, maybe. Okay, in the reverse direction. It will follow a path like this. After some time, you will see the bob in this position. It will swing to the other side also, but at one instant, it is going to be here. So let's call the initial position as A and this position as B. It crosses B and goes to the other side as well. As you said, it swings, pendulum. Okay. You all tell me, in a real life situation, as the bob moves from A to B, what all forces act on it? Aishwarya, can you tell the forces that act on it?
So weight, tension.
Weight will act, tension will act. In a real life situation, air resistance will also act. Let us ignore that. Okay. I'll write it here. But let's not consider that as of now. Okay, even if you consider it won't matter, that's not the question. I mean, it's not related to the question that I'm asking you. Let it be. Let's consider air resistance also. Okay. So the question is just to find out the sign of work done by these forces. I want you to tell me the sign of work done, positive, negative, or zero, is what you have to find out. First, by weight as the object goes from A to B. Next, by tension. Air resistance we'll discuss later. Think carefully and answer both questions. Only the sign, and you know sign depends on angle between force and displacement. So visualize that carefully and answer. What happened? I didn't get any answers. Okay. One of you tell me, weight is a constant force or a variable force?
Constant, sir.
For small distances above the surface of Earth, gravity is not going to change much. Mass of the object doesn't change anyway. So weight is mg and it's constant in magnitude as well as direction. Okay. So if you visualize weight of the, let's visualize the bob at different instants. Like this. Okay. You have to get used to all this. Now weight here acts in this direction. Here it acts in this direction. Always vertically downward, no doubt in that. Okay. Next thing to consider is the displacement of the bob. In which direction is the bob getting displaced? Is there a fixed direction in which the bob is moving, or its direction of motion is changing? Is it a linear path or a curved path?
It's a curved path, sir.
Curved path. That means the direction of displacement changes from instant to instant. Overall displacement is from here to here. Okay. You can use that also because the force weight is constant. You can make use of the overall displacement. Okay, let us do that. Why get confused and all? So this is the displacement vector. This is the weight vector. What is the angle between them? Acute, obtuse, or 90?
Good, sir.
Less than 90, acute angle. So work done by weight will be positive, negative, or 0?
Positive, sir.
Positive. In fact, gravity is what gives speed to this ball, no? Here, initially when we released it, it was at rest, but you know that as it comes down, it gains speed and it crosses over to the other side also. Where is that speed? Where is that kinetic energy coming from? From gravity only. So gravity is giving it energy as it comes down. Gravity is doing positive work. Okay, that part is done. Next is work done by tension. First tell me, as the bob moves from A to B, is tension a constant force on the bob or variable? Let's remove weight vectors. Is tension a constant force or variable? Is the question.
Variables.
Vanilla, how could you say it's variable?
So the tension increases because
Correct. It increases in magnitude. What you said is correct only. But see, we have not done any calculation. Your answer is correct. We have not done calculations based on that. But one thing we can directly tell, tension keeps changing its direction, right? Forces are vector quantities. Even if direction changes, you'll say it's a variable force. Okay. Rishi, do you agree with that or not?
Yes, sir.
And we can tell for sure that as the string rotates, the direction of tension changes with respect to ground. So at different instants, tension is acting in different directions, which makes tension a variable force in this case. See, you all have, I'm teaching you all how to approach questions based on work. Work is done by a force. Here you are asked to calculate work done by one force, weight, and the other force is tension. So first thing you have to find out is whether that force is constant or variable, because the formula will change based on that. Okay, weight was a constant force. We used F dot S, we got the answer. Tension is a variable force. Now, if force is variable, what is the formula for work? Aishwarya, tell me the formula.
Integration TF ds.
Okay, integration F dot ds. So tension dot displacement is what we need to do. Tension dot small displacements. Okay. Now you have to visualize the small displacements of the bob. At any instant, in which direction will the bob be moving? Any one of you? At any instant, what is the direction in which the bob moves? Is it moving in a fixed direction?
No, sir.
No. In that case, not just in this question, if an object moves along a curved path in any situation, the direction of motion, you will say, is tangential to the path. At this moment, its velocity will be directed, assuming it is going to the right side. At this position, its velocity will be directed that way. At this position, the velocity is directed this way. You will say it is tangential to the path. Okay, not you will say, I'm not forcing you to say, but that is the way it is moving there, no? Okay, so velocity is in this direction. And velocity, by definition, is small displacement by small time. So whatever is the direction of velocity, same will be the direction of displacement, small displacements. Okay, so remember, when an object moves along a path, straight path or curved path, small displacements are always tangential to the path followed by the object. So here in this problem, if you visualize, the small displacement here will be in this direction, tangential. Small displacement here will be in this direction. Here will be in this direction. Those are the ds vectors. So yellow vectors are ds vectors. These purple ones, purple, violet, whatever it is, are the tension vectors. Now tell me, what is the angle between tension T and displacement ds at any instant? Any position, what is the angle between them?
90 degrees.
90. Tension is along the radius. Displacement is along the tangent. You know radius is always perpendicular to the tangent. So the angle between tension and displacement is always 90. Then their dot product. What is the dot product of perpendicular vectors?
0.
0. The dot product here becomes 0 and integral 0 is 0. Therefore, work done by tension in this case is 0. Tension does not do any work as the bob swings. Gravity is the only force that does work. If you include air resistance, then yes, that becomes another point of discussion. We'll do that. But did you all understand how work done by tension is 0? How we approach the problem? Any doubt in this? Okay, you have to visualize the force and the displacement, then only your answers for work will be correct. Okay, now let us discuss work done by air resistance. This is also a qualitative discussion only. We don't want to calculate. We just want to tell whether it is positive, negative, or 0. Can any of you imagine and tell me the direction of air resistance as the bob swings down? Have you all felt air resistance anytime in real life?
Sir, while cycling in the opposite direction of the wind.
Cycling, riding a bike. Yeah. Even if you are simply sitting and a fan is blowing air towards you, you feel the force of air molecules on you. That is what is air resistance. Okay. So if you are moving forward on a bike, in which direction do you feel force from air?
Opposite?
Opposite
No.
means backward. Correct. Same thing happens with the bob here. Okay. We'll assume that the air is not flowing, air is at rest. But if the bob moves in the forward direction, the air molecules will automatically hit it in the backward direction. So even though the air molecules are not moving by themselves, if an object moves through air, automatically it will experience air resistance in the backward direction. Okay. So air resistance here will be in the direction opposite to its velocity. And if air resistance is opposite to its velocity, what is the angle between air resistance, I'll call it as FA, and the displacement at any instant? What is the angle between
180, sir.
180 degrees? Therefore, the sign of work done by air resistance will be negative. Work done by tension here is 0. And since air resistance is opposite to the displacement at every instant, the work done by it is negative. And it makes sense also. Air resistance tries to slow down the ball, no? From everyday experience, you can tell that. In fact, in a real life situation, if you pull the bob aside and release, it will swing for some time and finally stop. Means all its energy is gone. And that energy has been taken away by air resistance only. So that is proof, or that is an indication that air resistance does negative work on the bob. Doing negative work means removing energy. Doing positive work means giving energy. Okay. Fine. We'll stop it here for today. And I want you all to go through that worksheet once again and send me the answers. And especially these two questions. Person walking up a flight of stairs. What is the work done by normal force? I want answer with proper explanation. It's okay. You think carefully, give your answer and explanation. Maybe correct, maybe wrong, but make sure you have considered all what we discussed. Okay. And based on that, you give your answer. Same for this running case also. And there are some problems based on spring force, some problems based on work also, I think. Do those questions. Next class will be tomorrow. Tomorrow afternoon, not afternoon, evening, 4 o'clock. Is it okay? 4 to 5:30?
Sir,
Is
I
it-
have exam from 5.
Okay, yeah, you said you have exam from 5. Rishi, just for tomorrow, you just go through the recording.
Sure, sir. Okay.
Okay. Others is 4 o'clock. Okay.
Sir, I too
Hmm.
actually have exam at 3 to 6.
Okay. Fine then. We'll have class on Monday because morning time I'm not free. Only afternoon I can take. And okay, we'll have class on Monday. Next week sometime I'll cover it up. Okay, thank you all. Make sure you answer that worksheet, and tomorrow I'll send you one more worksheet also. Simple questions based on variable force, work done by variable. Some 4 or 5 questions will be there. Try to solve them. Okay, we'll continue on Monday.
Thank you, sir.
Thank you, sir.
Thank you, sir.